Screen. All right, so let's get started. As Navina said, my talk today will be about how you can own your own data lakehouse. And let's have a quick look. A couple of words, and Navina already introduced myself, but a couple of notes here around me and the background. So before joining AWS, I worked at companies such as Cisco and also MapR. So I do have a pretty solid background in infrastructure and also in the big data space. And then in the last couple of years, I also focused a lot on machine learning and AI, and I'm currently working as a senior developer advocate for machine learning at AWS. Together with a colleague of mine, Chris Freckley, I'm also co-authoring this book, Data Science on AWS, which actually talks about many of the concepts we're also talking about today in this session, but also showing you specifically from a data science perspective how you can build this end-to-end workflow on AWS. And part of the workflow is definitely how can I ingest data, work with data, especially in the context of machine learning, but also from a data analytical perspective. So let's get started here. So the agenda for today is I'm going to briefly talk about some of the data trends, and I'm happy to hear your opinion if you see them as well in your companies. And then I'm going to show you how you can build the data lakehouse. And I'm going to explain this concept also a little bit further in detail as we go along. And part of the concept of a data lakehouse is actually powered by a service of AWS called Amazon Redshift Spectrum. So I will also show you a demo how you can actually build your data lakehouse. All right, so let's get started with a couple of the data trends we're seeing in the industry. And coming from a big data background myself, the industry, we have talked about the data velocity, the variety, and the growth, the volume of data, right? And this has certainly been a trend for the last years already. But if there's one thing certain is that this trend won't slow down, right? We see data coming from more and more sources, whether it's online web services, whether it's IoT data, sensor data, social media. So the sources just, keep growing, and we're working with more and more data literally every month, every year. Also, the data is becoming increasingly diverse, right? We've also talked for a long time about the structured data and unstructured data, and we need means to handle the data formats and really kind of have tools that help us to get the insight from this data, regardless of which format it is. Another trend we're seeing is definitely that data is used by more and more people, right? So if you're coming from the traditional business analytics or data engineering background, data nowadays is probably also accessed by many more teams and people in your company. And some of those examples are machine learning data science teams, right? So we do have this large amount of data that we want to make sense of and get insights from. On the one hand side, for our businesses in the traditional business analytics and business intelligence view, but also helping to drive new initiatives, especially when it comes to making maybe predictive analytics and machine learning use cases. And this is really kind of also the last point here. Data is being analyzed by many, many applications. All right, so what is the challenge here? The challenge is that much of the data we're working with on a day-by-day basis is stored in individual databases many times or in data warehouses. And over time, those become data silos, right? So you have plenty of databases, maybe more than one data warehouse in the company, more and more data is coming. And this is just really not scaling anymore with the modern needs. So what we've been seeing in the industry as well for the last couple of years is this move towards building a data lake, right? And the idea of the data lake is really kind of bringing down those data silos and having a single place where you can ingest the data, govern the data, secure the data, but also make it available to individual teams and applications, right? Whether you're doing data warehousing on top of the data, whether you're running your BI reports, you're building dashboards, or you're feeding maybe machine learning projects. So this trend towards the data lake architectures is definitely helping to bring together the best of both worlds, right? So it extends or evolves your existing data warehouse architectures. And it also allows you to store the data in any format, right? So you don't have to worry in which format you ingest the data as you have with traditional databases or data warehouses. The idea of the data lake is really that you ingest the data probably in a very raw format as the data arrives, and then you can evolve and transform the data along the way, govern it, secure it, apply policies, and then make it available to any subsequent tools or architectures that you need to feed the data in. Also, the data lakes are very durable, available, and are able to scale with your data, especially if you're growing into the exabyte scale. And an important point I mentioned it a few times here is definitely data lakes must have the concept of security. You must be able to fulfill any compliant regulations and also give you all the tools and services to audit. And ultimately, you want to be able to run any type of analytics from data warehousing to maybe predictive analytics. So if we're looking now at this modern data analytics stack, it has evolved over the years, right? And here you can see just an example of how this data analytics stack might look like. So looking from the bottom up, the first step definitely is you need to have tools to move your data, right? How do I get the data into my data lake? And it's not only about static data, but you also probably have streaming data that is coming in and you need to kind of ingest into this data lake environment. And then on top of the data movement tools and services, you're handling the infrastructure for your data lake. You need to secure it, you need to manage and govern it, and you probably need some tools around data catalog and also ETL tools to further process the data to make it available to any upstream analytical tools. And if we look at this analytical layer on top, which basically accesses the data in the data lake, it could be of many forms, right? It could be traditional data warehousing, where you load specific data maybe into your data warehouse to run business analytics. Or you might have big data processing tools, right? You might be working with Spark to do some analytics on the data. Or you might be thinking of maybe I can do some serverless data processing, right? Leverage some of the new concepts that cloud is offering us to actually don't worry about any infrastructure and run analytics, data processing, or SQL queries without managing any infrastructure and really just firing up your queries onto the data set. And then in addition, if you're working with real-time data, you also want to be able to analyze the data in real time and also include operational analytics. And that is not the end, right, of the stack. So if you look on the top layer here, there's definitely dashboarding. Maybe you want to visualize the results, right, and present it to your business owners, to your company owners, etc. You want to create maybe applications that are driven by machine learning to run predictive analytics, whether it's maybe forecasting, whether it's analyzing maybe customer support messages coming in to classify it into maybe product categories, service categories, or catching the sentiment to be able to really be quickly and provide the best customer service you can. So as you can see, this data analytics stack evolved over the years, and there's many, many components that make up this stack. And if we're looking at the AWS portfolio of services, specifically here in the data analytics space, there's a lot of tools you can choose from that help you build exactly the use case you're looking for. So I'm not going to dive into all of those, but just for you as kind of an overview here, in the data movement space, you can see that there's a lot of services that help you to get the data into the data lake environment, whether it's database migration services, whether it's working with real-time data around Kinesis data streams, Kinesis Firehose, or if you're working with Kafka, there's also a managed service that gives you a managed Kafka experience in the cloud. And our famous Snowball and Snow Mobile, if you want to migrate petabytes of data securely. And then most of the data lakes we're seeing are based on S3. And there's a lot of capabilities also coming with the object storage in S3, which allow you, for example, to tier the data in the data lake given the amount and the age, for example. Also, for building up a data lake, there's a service called Lake Formation, which helps you to exactly those first couple of steps in building up a data lake and helps you to do this exercise not in months, but can speed it up into a couple of days. ETL service you might have heard of, AWS Glue, which also provides us with a data catalog. And then on the analytical side of things, one part that we're going to focus on today is the data warehouse, our Redshift service. But there's a lot more. There is a managed Hadoop offering and Spark offering with Amazon EMR. And we will also see in the demo a service called Athena, which will help you to run interactive queries on your data in the data lake without really having to manage any infrastructure or service setup. And then on top, there's almost too many services to list it here in this slide. Basically, the whole stack integrates with a portfolio of services that the AWS cloud gives you, whether it's in the machine learning space with Amazon SageMaker or any of the high-level services, AI services, in terms of text recognition, speech, vision, etc. All right. So, also worth mentioning is that AWS supports a lot of the open standards, formats, and Apache open source projects. So, if you're working in any of those, you can be assured that AWS makes it easy for you to keep working with those projects and standards and gives you a managed experience and really also contributes to many of those projects to make sure you have the best experience running them on the AWS cloud. All right, so for the rest of this session, I want to dive a little bit deeper into one of those services, which is the Amazon Redshift, which is the cloud data warehouse service from AWS. And I don't gonna go too much here into this slide, but basically what I wanna touch on is the first point mentioned here, which is the capability to integrate with the data lake. And we're gonna see when we're building our data lake house, what this means and which benefits this brings to us. Also, there's a lot of capabilities around Redshift as a data warehouse, which improves the performance. So AWS, for example, has developed house internally compression algorithms that help you to just compress the data even more efficient and have built-in capabilities to scale the data warehouse, whether it's horizontally, whether it's vertically, given the load and the current requests against data warehouse. So a lot of really good things. Obviously, always the number one priority is to keep data secure and give you all the tools needed to comply with any regulations. So also Redshift is certified with all major industry certifications and also gives you a lot of services and integrations with a broad suite of security tools. And always, we do have cost in mind. So there's a lot of built-in capabilities to also help you to keep the cost footprint low and help you really to get most out of your data. All right, but let's now jump into the more interesting part, which is how can I finally own my own lakehouse, right? So let's see how we can do this. And I want to reveal here as well what we mean when I talk about a data lakehouse. So I guess the majority of us is familiar with the idea of a data lake. So as I said, the data lake is really where you ingest all of the data that is coming in. You govern your data, you secure it, etc. But it is really a mix of structured and unstructured data, and it can potentially grow to the exabyte scale or even larger, right, over the years. And then in contrast, here, if we look on top in this little house, which represents your data warehouse, this is really where your business data lives, right? So the data warehouse is focused around structured data, where you run a lot of complex queries to generate your business reports. So when we talk about building this data lake house approach, what we mean is having one foot really in the data lake and having one foot in the traditional data warehouse in Redshift in the business data. And the idea here is that you don't have to move any of the data. You have your data warehouse environment where you run your queries and you generate the reports, but you can also tap now into this maybe exabyte scale of data that is in the data lake to get data to enrich your queries and then present it in the reports. So let's see how we can build this. And again, here is a quick summary, the data lakehouse, what it means. As I said, it's having one foot in the data warehouse world and one foot in the data lake. And if you wonder like where to store which data, right, where is kind of the boundaries between, you would definitely store all of the highly structured, frequently accessed data in your data warehouse environment, but keep the exabytes of structured and unstructured data in the data lake, which is built in many cases on top of S3. And then you're able with this approach to query seamlessly across both to provide this unique insights and that you wouldn't have if you only look at maybe the current set of business data that is in the data warehouse, or if you only look at the data that is in the data lake. And the important part here is you can do this without moving or transforming data. And the lakehouse architecture is powered by mainly three capabilities of Amazon Redshift. One of which is Redshift Spectrum. And Spectrum, which we'll also see in the demo I've brought with me, is the capability to query open format data directly in S3 in the data lake without having to load the data to Redshift. So basically, you're firing up your query from Redshift and tapping into the data that is in S3. And then the other two legs here are really the data lake export, which also gives you the capability to contribute back to the data lake. So let's say you're pulling in some results from the data lake that you queried, and you're enriching the data in the data warehouse. And at the last step, you also want to write the data back into the data lake, the enriched data, because maybe you want to provide it to additional teams that run similar analytical queries. So this is done with a feature called Data Lake Export. And the export is done in the PerK file format. And I'm also going to touch quickly on that in just a bit. And then the third part here is Federated Queries. And Federated Queries enables Redshift to not only query in S3, but also run the query across your databases in RDS or Aurora. So any Postgres SQL stores. And with that, you really have all of this data available for you to tap in, push down the execution, the actual query execution to those systems, and just retrieve the results back into your data warehouse. All right, so here's a quick overview of how Spectrum works. So again, Spectrum is a capability or a feature of Redshift that allows you to run those SQL queries on data that is living in S3 in your data lake. And it looks like as any other table you have in Redshift. And this really lets you query potentially exabytes of data without having the need to move the data in any way or transform it. So the query is pushed down to the data lake and executed on the Redshift Spectrum engines and compute nodes, which are fully managed by AWS. And then just the results are transferred back. And this really allows you to keep your data warehouse very lean because you only ingest the relevant business data and you store the, terabytes, exabytes of data in the data lake. Then the federated query, which I mentioned, gives you the capability to not only query the S3 data lake, but also run queries on the relational data, which might be stored in RDS or Aurora databases. So a similar idea really here is to have this unified analytics across the data warehouse, the data lake, and your operational databases. And with this, you can also run the query on the transactional data you might have in those systems. And then the other part that I mentioned is the contributing back data to the data lake, which is called the data lake export. And maybe you've heard of the PerK file format, right? So PerK is a columnar-based and optimized file format, which makes it really efficient if you're running those analytical queries because you can query on a column base. And if you're using this data lake export functionality, it basically writes out, it unloads the data from your Redshift data warehouse in PerK to S3. And this is really, as you can see here, a simple unload command. And then once you contributed the data back, you can then use the data, for other applications that might need that, or you can use tools as shown here, like the managed big data environment with Amazon EMR, if you're running Spark queries, for example, or if you're running the Amazon Athena, which is an interactive query service on that data. All right, so here is a one last slide, which kind of shows you the life of a query, and then we will have the demo. So here you can see the overall architecture, right? And when we start from the top here, you can see you would interact with Redshift using one of your SQL clients or any of your BI tools using a JDBC or ODBC connection. And you're basically defining your query, as we can see here on the top right. So let's say query select count star from an external table, and the external table basically refers to the data in the data lake, and then do everything you want to do, group by, etc. Right? So you're writing a normal SQL query here. And the way this works is you're connecting to Redshift through this JDBC ODBC connection. And the first step here is the leader node, which basically gives you kind of this SQL JDBC interface and also optimizes the query and applies ML techniques to figure out how to compile the query and also where to run the data query on which Redshift node, right? Redshift is highly distributed, MPP, so part of the data live on different nodes. And when we're querying S3, so the query is still, optimized and compiled. And then as a next step, the query plan is sent to the compute nodes. And below the compute nodes, you can see that we do have a fleet of those Spectrum nodes, which are fully managed by AWS, so you don't have to care about those. And once the compute nodes obtain the partition info from the data catalog, where to find the data, they optimize, they prune the partitions, etc. And then each compute node issues multiple requests to the Redshift Spectrum layer, which then accesses the data in S3. And once this is done and the results are coming back, the Redshift Spectrum projects filters, joins, and aggregates the data as needed per the query execution plan. And then the Redshift compute nodes do the final aggregations and joins with the local Redshift tables. So when you're enriching a local table with that information, this is done again in cluster, and then the result is sent back to the client. So this is kind of how the query gets executed when you're tapping into the data lake with that SQL query. All right, so I know this was a lot of information. So the best way to show this is a demo, right? So I'm going to jump here into my AWS environment, and I'm working out of Jupyter Notebooks. This is because all of the code here I'm showing you is part of the data science on AWS book and code repo. So in here, as I said, we do have the whole pipeline from ingesting data to preparing it specifically for machine learning projects. And this part around Redshift is part here in the ingest section. So if you want to look at the code later after the session, after the conference, feel free. I've put in the link to the GitHub repo in my slides, and it's a public repo, so feel free to have a look at that. All right, so in the ingest part here, what I'm showing you is how to get the data into R3. And then I do have already a Redshift cluster running here, so I can show you how to actually run this spectrum query and how to enrich the data. So I'm going to zoom in a little bit here so you can actually see it a little bit better. So the idea here about the ingest is that most of the data really ends up in an S3 data lake, whether it's applications writing it in or you have crawlers set up, etc., or any of your ingest methods. And then depending on really what team you're in, right, you have a set of tools to work with the data. So if you're a machine learning engineer or data scientist, you probably don't want to even bother about the data warehouse. You just want to run a couple of easy queries on the data and then start prototyping your machine learning model. But if you're coming from the business intelligence or data analyst background, and you might be more familiar working with databases and data warehouses, right? And this is here where Redshift comes into place. And we do have all of the demos in here, and I'm going to show you now the part where we're working with Redshift. So what I've done here just in preparation, I'm going to show you this, is a simple step here. So I'm just simulating the data coming in by copying my raw data into my S3 bucket, which is my data lake. And as the data set here, I'm using the Amazon Customer Reviews dataset, which is a public dataset you can also use for research. And this is basically 150 million reviews from the Amazon.com marketplace. So whenever you go on Amazon.com and you click on a product, right, you can see those star ratings and customer reviews, whether people like the product and maybe it has a 5-star rating, which is the best, or a 1-star rating. And I've been using this customer reviews data set here to ingest into my S3 bucket. So I'm basically copied a couple of those reviews into my data lake. And then what I also did is I set up the Athena service. Athena is an interactive query service based on Presto. Maybe you're familiar with that, which is an open source distributed SQL engine. And with Athena, you can fire up SQL queries on the data. So I've also created this meta information, which will basically populate a data catalog in the backend for me.
Hi,
So those are
Anshu.
a couple of steps. Yes.
Yeah, sorry to interrupt. As a reminder, we have 10 minutes before the session ends and to answer any questions that we have.
Yes. So I'm
Thank you.
planning on doing 5 more minutes, and we have a little bit
Sure,
of
sure.
Q&A time. All right, perfect. So I've registered the data here. So this ends up in the data catalog service, which comes in handy here in just a second. And there's a couple of ways actually to create PerK data. So just as a side note, Athena is also possible, capable of writing, converting data to PerK. But we want to see how Redshift does that, right? So one of the exercises here is to create a Redshift cluster. So I've created my cluster. It's a little cluster. Just have 2 nodes here. It's available and running, and it's pretty, idling here, so I don't have too much data in here. But basically, you can either use the console here to create this, or I've done this programmatically from my Jupyter Notebook environment. But we do have the cluster available here. And then as a next step, there's a couple of ways to work with it, right? So you can either load data into Redshift. And I've done this as a first step because I want to have some data that is living locally in my Redshift cluster. So what I've done here, and I scroll down, we're setting up the connection, checking that the cluster is available. And the first step here is to create a schema. So I'm creating an external schema which refers to the data catalog where I registered my S3 data. And with that, I can run a sample query here already using Spectrum. So again, by using Athena in the first notebooks, I've done that really to create the catalog entries. And I'm jumping here quickly to a service called AWS Glue, which you might be familiar with in the ETL space, but it also comes here with a Hive Metastore data catalog service. And I've created a database and I've registered here, as you can see, my reviews data, which is originally in TSV tab separated. And I have this now available, and this means that I can refer to it through this external schema where I just map the data catalog. And this is basically this command here. And then I can run a SQL query. So I can do a select, product category. I can count the star ratings for my reviews. And by calling this Athena schema, which points to the data catalog and this table information, I can now query the data in S3 from my Redshift environment. And here you can see I have two categories in here, digital video games, which have 145,000 reviews, and the digital software product category, which has 102,000 reviews. All right, so this was a query straight into my data lake, right? By just basically connecting to my data catalog, which has this external table schema information on top of S3 data. All right, so what I'm doing here next is also loading some data into Redshift. So here I'm physically moving data just to show you how I can run a query across both systems. So what I'm doing here is really just loading data from 2 years. So the reviews data is split into years from 1995 to 2015. So what I'm doing here to simulate more of a business approach is loading the data set from 2014 and 15 into my Redshift physically. This is done here. So again, I'm inserting this into tables that live in Redshift. And what I can then do, and this is the more interesting part here, is to use Spectrum to query both. So I'm running a query, and I zoom in here again a little bit so you can see the graphic here. So what I'm doing is I'm querying partly data that lives in S3, and I'm going to query everything that is 2013 and older. And I'm also querying Redshift, which now has the data which is up to date 2014 and 15, right? So maybe you want to offload older data to S3 to your data lake and query the recent data in Redshift. So this is what I've done here, constructed. I'm connecting to Redshift, setting up the credentials here from my Jupyter environment. And I'm going to do this now with the union all statement. So here's an example that just runs query against 2014 and 15 in Redshift, just to see what the numbers are. So I'm counting the star reviews. And then you can double check if you're doing the same in the data lake that actually the numbers match. And as the final here, which I want to show you, is how you can query both across Redshift local data and the data in S3 in a single query. And I'm showing you here the print statement. So we're doing a select, and I'm union the 2015 data from Redshift with the 2014 data. And then I'm doing another union all, and the last query here queries the data in S3. So I'm doing here, you can see the schema is Athena, which is the S3 bucket, and the results are coming in. And here you can see the results from the SQL query. So imagine 2015 and 14 only live in your Redshift cluster, and everything older is coming from the S3 data lake. But now you've executed a single query, union the results together, and you do have a single table view here with the data. And here I'm just counting the reviews across those categories per year, parts coming from the S3 data lake and parts coming from the Redshift environment. Isn't that cool? And there's one more example. I'm not going to go too much into detail, but you can contribute this data back to your data lake with this data lake export command. And I'm just scrolling down to the SQL command here. I guess this is the most interesting one, which is basically, as you can see here, an unload command. So you're doing a select what you want to write back out and doing an unload. And this writes the data back into your S3 bucket. So if I go here to my S3 environment, I do have PerK from Redshift. And if I click in here, I basically wrote out examples from 2014 and 15. And if I click in here, you can see the PerK data for the two categories. And if I click in here, you can see the PerK files. So any other application could pick up the data again from the data lake and keep on working with it. All right, so to wrap it up, here's a little bit of an overview when to choose which, right? When do I do Redshift? When do I do EMR? And when do I do Athena? And Redshift is really the fastest query execution. So if you're doing complex SQL queries, this is definitely where you want to have Redshift. If you want to run custom applications, Hadoop, Spark-based, etc., you can look at EMR. And if you don't bother, if you come from maybe a data science ML background, you just want to query Athena, using Athena to query the data, this is also kind of the serverless SQL approach. All right, and here's a couple of links how to get started. The book is actually on pre-order right now on Amazon.com. We do have a section that discusses the data lakes and how to build this data lakehouse. All code is in our GitHub repo, and here's also a couple of links on how to get started with AWS and in specific Amazon Redshift. And with that, thank you very much for joining my session. And we do have time left for Q&A, and I'm also going to stick around if you want to reach out directly. Thanks so much.
Thanks, Sanjay. Like I, being a student, have learned a lot from this session about Amazon Redshift Lakehouse and its architecture. So I don't think we have time for Q&A. Can we just quickly go for one or two questions,
Sure.
Jitesh?
Yeah, we actually have two questions here.
Yeah.
So if you can get some input from speaker. One question is, what data formats do you mean when you say query open format data?
Yes, so the open formats data is, for example, JSON, PerK, Avro, CSV, etc.
Thank you. One more question. Given that you can query S3 data in place of using Redshift or Athena, why choose one over the other?
Yeah, and this was basically my last slide that I added there. Feel free to revisit that in the handout, which I attached. Athena is basically the easiest one. So Athena is really just defining the meta schema for your data in S3, and then you can write SQL queries and fire them at the data. So you don't have to set up any warehouse environment with infrastructure, instances, etc. It's kind of a serverless SQL, if you think about that. It's based on Presto, so super easy to use. And if you're working really kind of, more on a business intelligence, business analytics team, and you need a data warehouse to run complex SQL queries, joins, aggregates, that is more the job for a data warehouse. So this is when you would use Redshift. But it really kind of depends, what's the actual business use case. If you really just want to query the data, I would go Athena. If you're building and you need a data warehouse for all of its, capabilities, this is the other way to go.
Excellent. Thank you very much. And we have the similar use case, and the information is very, very helpful. Thank you.
You're welcome.
Any more questions, Jitesh? I think
So there is just one quick follow-up. There is
yeah.
need transfer any data from existing data warehouse can query directly. So that's what John Lu wants to confirm.
So on the data transfer, on the movement of the data, that is. So yeah, so if you just query the data in S3, you don't have to move it, right? So basically, you're pushing down the SQL query and the calculations also to the Spectrum managed layer, and then you get the results back. The part where I loaded data was really just to get some data in my data warehouse. But the basic idea here is exactly, so you just keep the relevant data, the highly structured business data in your data warehouse. And then all of the exabytes of data you might have in the data lake, you can keep there. You push down the query, it gets executed, and the results are sent back. And the results is what you can work with then in the data warehouse in Redshift. That's the beauty exactly of that you don't have to move any data.
Okay, thanks, Anche. We are running late actually, so we are going to end this now. Thank you, Anshay, for your presentation, and I appreciate all the attendees for the questions and interactions during this session. Please contact the speaker if you have further questions regarding this topic. Please provide your comment and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA 2020 community. Thank you for joining today's presentation, and I hope you can gain some insights from this session. Have a wonderful day, and thank you for being part of this year's DataCon LA.
Thank you very much for joining.
Thank you.